Hello, my name is Krzysztof Gajos, and I lead the Intelligent Interactive Systems group at Harvard University. I worked on this project with Professor Lena Mamekina from Columbia University. Together, we looked at whether people engage cognitively with the information generated by AI systems when people engage in decision-making tasks. Specifically, the context of this talk is AI-supported decision-making. Imagine, for example, a doctor trying to select the best treatment for a patient. They may be assisted by a computer system that articulates the decision task, shows them the prediction of some AI model, alongside with an explanation generated by that model. And the person's task is to integrate their own knowledge with that presented by the AI system to come up with a high-quality decision. The key message of our work is that there is compelling evidence that people do not engage cognitively with the information generated by AI systems and consequently make lower quality decisions than what would be expected in such settings. And we also will present novel evidence showing that if people are given just the information needed to make their own high quality decision, but no actual decision recommendation, they do cognitively engage with such information, and hopefully this will lead to higher quality decisions later on. For context, when AI-assisted decision-making became an area of intense study, it was taken for granted that people assisted by AI systems will make better decisions than either people or AIs alone. However, essentially all studies that look at the performance of human AI teams on decision-making tasks show that such teams perform worse than AIs alone. Some insight into what's going on can be gained by disaggregating the results and separately looking at situations when AI makes correct versus incorrect decisions. Such results demonstrate that people often follow the AI even when the AI makes incorrect recommendations, demonstrating that people engage in high level of over-reliance on the AI systems, which in turn indicates that people are not integrating the information that they have with the information provided by the AI to generate high-quality decisions. Many people have contributed such results. One of our studies showed such results in context of clinical decision-making. Doctors assisted by an AI made no better decisions than they did when they worked with no such assistance, and adding different kinds of explanations did not improve the situation. So just adding the explanations to decision recommendations is not sufficient to help people make high quality decisions. We hypothesize broadly that human cognitive engagement moderates the effect of explanations and recommendations on human decision-making. So where we need to intervene is making sure that people really engage with the information that AI provides, and not merely at providing better information for people. In an earlier study, we examined this hypothesis from one angle, namely we explored the effect of cognitive forcing functions on human over-reliance on the AI systems. Cognitive forcing functions are interventions designed to disrupt heuristic processing of information and encourage people to process information more analytically. An example of a cognitive forcing function, which we call the update design, first presents people with the decision-making tasks and asks people to make a decision without the aid of an AI system. And only after people make their own decisions are they confronted with the recommendation and explanation generated by an AI assistant. And then they're given a chance to revise their decision. The idea is that if people are confronted with a contrast between their own decision and that of a system, they will very carefully examine the evidence that they used in their own decision-making with the evidence provided by the system and resolve the difference in a thoughtful manner. And indeed, the results of our studies demonstrated that when AI was making incorrect decisions, people in the cognitive forcing function conditions over-relied on the AI less than people who were not in the cognitive forcing function condition. In the context of this paper, we looked at another piece of evidence related to human cognitive engagement with AI-generated information. Namely, we looked at incidental learning. When people are assisted by others on decision-making tasks, they perform better in the moment, thanks to the help, and often they learn from the interaction, so the next time they're presented with similar challenge, they can solve it on their own. Such incidental learning can only occur if people cognitively engage with the help that they're given. Thus, we hypothesized that when people interact with simple explainable AI systems, where they're presented with a decision, recommendation, and explanation, they would not engage cognitively, and therefore we would see no evidence of incidental learning. Conversely, we hypothesized that in cognitive forcing function conditions, people would engage cognitively with the material and we would observe evidence of learning. And based on research from the group of Perso Karahelios, we also hypothesized that if people are just presented with an explanation, giving them sufficient information to make a decision on their own, but no actual decision recommendation, they would make high quality decisions in the moment, and also they would learn. We performed our study in the context of a nutrition decision-making task where people were presented with pairs of meals and were asked to decide which of the two meals has more of some macronutrient. We had two baseline conditions without any AI support, and we also had 3 conditions with AI support. The simple explainable AI condition, in which people were presented with a decision recommendation and an explanation. The update condition, in which people first made the decision on their own, and then they were shown a decision recommendation and an explanation, and the chance to revise their decision. And finally, the AI explanation only condition, in which people were shown an explanation, however, no explicit decision recommendation. We found that, as expected, in the simple explainable AI condition, people did not learn. Here, I should explain our 2 baseline conditions. The no AI support or feedback baseline condition was one in which people performed the unaided tasks without AI support, and they only received very minimal feedback on their performance. In the other baseline condition, people received expert explanation on the correctness or incorrectness of their decisions. Prior research demonstrated that the first baseline condition should only result in minimal learning, whereas the one with the expert feedback should result in substantial learning. As we can see, people in simple explainable AI condition learned no more than people who received no support and no feedback. Surprisingly, people in the cognitive forcing function condition also did not learn from the interaction. However, people who only received an explanation but no explicit decision recommendation learned as much as people who received expert feedback. Thus, we conclude that there's really compelling evidence that people do not really engage with the information provided by simple explainable AI systems. However, when they are put in a situation where they have to perform some cognitive work on their own, namely translate useful information into an actual decision, they do engage cognitively with that information, learn from it, and hopefully will also make high quality decisions in complex situations. However, we have to note that in this study, our simulated AI was always correct, so we still do not know how robust this approach is in situations when AI makes incorrect recommendations.